Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math. And this is another session of Tutor Me Senpai. Welcome back, everyone. Today we're going to be jumping into an 8th grade topic, evaluating piecewise functions. Now, this is going to be part 3 of our 3-part series, in which the first part was graphing linear functions, the second part was graphing linear piecewise functions, and in this one, finally, evaluating piecewise functions. So if you haven't seen the first 2 parts of this series, I recommend pausing this and going and checking that one, because we're going to just keep building on what we talked about. If you have any questions, feel free to put them in the comment box below. And if you have any questions about your own homework you'd like to see on this channel, remember you can visit me on Facebook at Tutor Me Senpai, and you can tell me all about it there. If you found this video helpful, remember to leave a like, it really helps the channel. And while you're at it, hit the notification bell and smash the subscribe button so you know exactly when I drop my next videos. Well, without further ado, let's talk a little bit more about evaluating piecewise functions. Now, before we jump into evaluating our function for today, I want to give you a little bit more encouragement, because if you know how to evaluate a regular function, evaluating a piecewise function is not going to be much different from that. If you have no idea how to evaluate a regular function, no worries. It's very easy. So let's say we have this function, f of x equals x plus 1. And you want to evaluate this function at -5. Well, evaluating a function simply means wherever you see this -5 or whatever number is here, you put it in for every x. You see this x is here. We want to do the same thing with this -5. So instead of having an x here, it will be -5. And I like to put these in parentheses. You don't necessarily have to, but it comes in handy a little bit later. And then plus 1. So this looks just like this, except everywhere there's an x, you put a -5. And then you simply combine these. -5 plus 1 gives you a -4. If you were to do 10, everywhere there's an x, you place a 10. So that's going to be 10 plus 1, which gives you 11. So this is what we mean by evaluating functions. Now you might be thinking, well, how is evaluating a piecewise function going to be pretty similar to this when you have multiple functions? Let's say you have the function f of x plus 1 and -x minus 2, right? And you want to evaluate, let's say, -3, and you want to evaluate 5. I like 5 for some reason. So you might be thinking, how do I know which one? Because there are 2 functions here under this piecewise function. This piecewise function has 2 pieces. How do I know which one to plug it in? You don't want to do both, right? You can't do -3 plus 1 and then -3 minus 2. Like, you can't have both of them. You have to choose one. But luckily, there's an extra part to our piecewise function that tells us exactly which one to choose. That's when we look into the domain. So this is going to be defined, let's say, everywhere where x is strictly less than 0, and this is everywhere where x is strictly greater than or equal to 0. So using these domains here, we know exactly which functions we're going to be using for which values of x. Any value of x strictly less than 0, we'll focus on this one. Any value of x strictly greater than or equal to 0, we're going to focus on this one. So revisiting this question here, f of -3, which function are we going to look at? Are we going to look at the top one or the bottom one? Well, is -3 strictly less than 0, or is it greater than or equal to 0? Well, it's strictly less than 0, right? So this tells us we're going to be using our top function. So it's going to be looking like everywhere there's an x, you place a -3 plus 1. And when you evaluate that, you get -2. So -2 is the answer for that one. F of 5. Now, is 5 greater than or equal to 0, or is it strictly less than 0? Well, it's definitely not strictly less, so it has to be greater than or equal to 0. So that means we're going to be using the bottom function. So everywhere there's an x, you place this 5. So this negative, I put in parentheses. I like to put in parentheses. It keeps things nice and neat. Minus 5, right? Because there's a minus here. Minus 5 minus 2. So what's a negative 5 minus 2? Well, that's negative 7. So this is the answer for this one. F of negative 3 uses the top function only because of the domain. F of 5 uses the bottom function only because of the domain. So remember, whenever you're having to evaluate a piecewise function, you have to take into account what is the domain you're looking at. If your x is not in a domain of a certain function, you can't plug it in. The definition of a domain is all possible values of x for that function. And this is saying no x in the negatives is going to be a possible value for this function. So this does not happen. Likewise, this does not happen because this is saying all x's that are positive and even 0 are not going to be possible for this function. So now let's jump into our question for today. Our question says we have this function f of x, and you notice it's a piecewise function. And the piecewise function has two pieces. The top piece says we are the function x plus 2, and our domain is all values of x less than or equal to negative 7. Our bottom function is 8x, and our domain is going to be all x's between negative 7 and 12. However, negative 7 is not included where 12 is. And then we're going to take this piecewise function, and then we're going to try to evaluate this expression here. So this says negative 9 times whatever the value of f of negative 7 is, plus whatever the value of f of 0 is. So we're going to use what we talked about previously and focus in on our domain to help us figure out which functions we're going to be using when we plug in these numbers in. So let's start with f of negative 7. This negative 7, in which function is negative 7 part of the domain? Here, we have negative 7 strictly less than x, which is less than or equal to 12. Is negative 7 part of this domain? No. This is strictly less than, not equals. How about this one? This says x is less than or equal to negative 7. Well, because we have that equals, we know that negative 7 is part of this domain. So you can actually rewrite this as negative 9, put a parentheses here, negative 7, and you can put that in parentheses, a smaller one, plus 2, and then close the parentheses. We're replacing this f of negative 7 placeholder with the actual function and our value of x plugged in. Now let's look at the second one. F of 0. Is 0 part of this domain? No, because this is not looking purely at negative numbers. This is all negative numbers less than or equal to negative 7. How about this one? Well, this looks at all x's between negative 7 and 12. And although negative 7 is not included, 0 is going to be, right? Because negative 7 and 12 on either ends, there's going to be a 0 somewhere in the middle. So we're going to be using the bottom function. So I'll put another parentheses and do 8, parentheses again, times 0. Because everywhere there's an x, I want to place a 0. So you see, we rewrote this expression here where we had these placeholders for f of negative 7 and f of 0 with the functions that we're supposed to be looking at. And we plugged in our values so we can now fully evaluate this to figure out what our answer is. So negative 9, and this is going to say negative 9 times whatever's in here. Well, what's negative 7 plus 2? That's going to be a negative 5. Plus, well, what's 8 times 0? Well, anything times 0 is going to be 0. So now we have negative 9 times a negative 5. Well, what's negative 9 times negative 5? Well, we're going to get a positive first off, right? Good. So we're going to have a positive 45. And that is our answer for today. When we have negative 9 times f of negative 7 plus f of 0, we realize that our first function is going to use the top function. Our second one is going to use the bottom function. And when we evaluate everything by plugging in our values, we get a positive 45. Well, I hope you're able to follow along with today's example. If you have any questions, remember you can always tell me about it in the comment box below. I would love to help you out where I can. If you have any questions about your own homework you'd like to see on this channel, well, visit me on Facebook at Tutor Sempai. If you found this video helpful, remember to leave a like, it really helps the channel. And while you're at it, ring the notification bell, smash the subscribe button, and share with a friend who could probably use the help. Well, that's all the time I have for today. I really hope this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Sempai.